Hello everyone. How are you all? I hope सब बढ़िया. So today we will be solving this problem Leetcode 2044 from the number of maximum bitwise or subsets, and which is a mid level question and a part of the problem of the day of daily Leetcode challenge, daily coding challenge at Leetcode. So let's start without any further delay. What this problem states: given an integer array nums, find the maximum possible bitwise or of a subset of nums and return the number of different non-empty subsets with the maximum bitwise OR. Okay, so there they have given the definition of a subset. An array A is a subset of an array B if A can be obtained from B by deleting some elements of B. Okay, two subsets are considered different if the indices of the elements chosen are different. Okay, so there can be multiple elements, multiple same elements, but their indices should be different in order for two subsets to be considered as different. Okay, so they have solved an example. Let's see what are our observations. So our observations are we need to find what could be the maximum bitwise OR of the given values. Okay, yeah, we have to find what could be the maximum bitwise OR of any subset, and then we have to calculate the number of possible subsets that have OR values equals to the maximum OR value possible. So whatever maximum OR value we will get from any subsets, then we have to calculate the number of possible subsets that have the OR value equal to that OR value. Okay, so we will be solving this problem using three different approaches. And what could be the let's start with the brute force thinking. What could be the brute force? Brute force will be like we have to generate all subsets. Yeah, you are right, generate all subsets, and generating all subsets is the key to solve this problem. Okay, so approach one is using hash and backtracking. Okay, so let me start the by run, so we will get the better understanding of this approach. So we have to keep an hash map. Okay, now we will start the recursion. Initially we are at 3 and our OR value is 0. Now we have these two possibilities, whether we pick this 3 or don't. If we pick this 3, then our OR value will be 3, and if we don't, our OR value will be 0. Now we are at this 2. Okay, so 2. Okay, so now we will be having two different possibilities, whether we take this 2 or don't take this 2. If we take this 2, then the OR value is 3. If you OR 3 and 2, we will get 3, and if we don't take 2, then our OR value remains 3 also. Okay, 3. So now we are at this 1. We are at this one. Okay, now again two possibilities, whether take if we take, our OR value will be 3. If we don't, it will still remain 3. Now we are at this 5. Okay, so we are at this 5. Two possibilities again, take, don't take. If you take, your OR will be 7. If you don't, it will be 3. Now the array is exhausted, so you have to put this 7 in your hash map, whatever map you are using, and this will be 7,1, and this 3 also, 3,1. So I am not going to draw the full recursion tree here, but if you try to draw the full recursion tree, you will get the value of maximum OR as 7. 7 will be the maximum OR value we will get, and the count of that will be 6. Like we will having the 6 different subsets that will be leading to this or value 7. Okay, so what is the time complexity in here? Let's analyze this. So we are running recursion over this array. There are n elements, and for each elements you have two possibilities, whether to take or not take. For each element you are giving this possibility. Okay, so that will be surely two possibilities for each element, each of the nth element. This is big of n. Okay, so to the power n for the recursion, and for the operations in the hash map, we can say it could be taking log of n. Now you will be wondering what is m. See, m could be the possible number of unique keys in the hash map, and in the worst case it can also lead to the power n. Okay, so it will be big of to the power n into log n, the overall time complexity. If we talk about space complexity, space complexity for this approach can also lead to big of to the power n, since there can be different unique OR values for each and every subset. So we have to store to the power n keys in our hash map. Okay, so let's move on to the second approach. Second approach is using hash and bit masking. See, what could be the number of maximum possible subsets from this array? Let's take this, like we can have 3 comma 2, we can have 3 comma 2 comma 1, we can have 3 comma 2 comma 1 comma 5, we can have 3 comma 2 comma 5, we can have 3 comma 1 comma 5, we can have 3. I think that's all for 3. It can be sorry, it can be 3 comma 1 also. It can be 3 comma 5 also. 3 3 2 3 2 1 3 2 1 5 3 2 5 3 1 5 3 5. I think that's all. That's all for 3. For 2 2 comma 1 2 2 comma 1 2 comma 1 comma 5 2 comma 5. Okay, that's all for 2. For 1 it can be 1, it can be 1 comma 5. For 5 it can be only 5. So these are the possible number of subsets. How many are these? 1 2 3 4 5 6 7 8 9 11 12 13 14 15. So isn't it isn't it same as 2 की power n minus 1 subset? One is the empty subset which we don't have to consider, and n is the length of the array. So if with 2 की power 4 minus 1, which will be ultimately 15. So we know we have the maximum subsets will be 2 की power n minus 1. So we'll be taking this in our consideration and use the bit masking approach. We will loop from from 0 from 1 actually, because we don't have to consider the empty subset, so we will be leaving 0. So we will loop from 1 to the power n less than equals to the power n, and then we will be okay. So we will be looping from 1 to the power n and generate the binary value. Like hypothetically we will see the binary values, what I am trying to say. If we try to generate binary from 1 to 15, then it will be look like this, this will be 3. Sorry, my wait. Okay, and so on. It will be leading to all ones. Okay, so now we will be checking each and every bit position one by one for each possible value of the binary number. Like we have a 0 at, we have a 1 at this position, so we have to consider this element in our XOR value, in our OR value. Okay, we have 0, so no, not consider. We have a 0, so not consider. We have a 0, so not consider. Okay, then in the next step we have a 0 here, not consider. We have a 1 here, consider this, only this, and not 3. So by following this one time, we will be generating all of these possible subsets. Okay, so and let me simply pseudocode this for you, so you will be having the better understanding. Wait a minute. Yeah, so first of all we have to find the total elements, which will be nothing but this much. Total number of possible subsets will be this much, to the power n. It is equivalent to the power n. Okay, so now we will be looping from 1 till total -1 inside loop. You will be having a OR variable, which will be initialized to 0, and then you will loop from 1 to n. Okay, and for each we will be having mask is equals to 1 left shifted by value of j. Let's consider this loop is running on j, and this loop is running on I. Okay, so inside this we will be having a mask, and then we will check whether if the end of this I and this mask is not equals to 0, then we have to take this element. Remember, if we have a 1, we have a 1 over this position, then we have to take this element. So or nums of I, my bad, nums of j, and when our inner loop ends, we have to put on in map whether this or +1 in map. So this is the pseudocode, and then we will be having the maximum the key with the maximum XOR, and we will return the value of that XOR. Okay, so the time complexity of this is like 2 to the power n, since we are generating this much subsets. So for definitely it is taking 2 to the power n operations, and also we are running this inward loop from 1 to n every time. So it is, and this much time complexity, it is much bigger than the previous one. So this is not the optimal approach, this one was a better approach, hashmap plus backtracking. Now we will be moving forward to our optimal solution, which is using bit manipulation and backtracking. So before discussing our optimal solution, we have to find one thing, which is here, what could be the maximum OR value of a particular array. So what could be the maximum possible OR value? See, OR means performing an OR operation on any number will be increasing the set bits only. It will not decrease the set bits, never. If initially we have a number like this 0 1 1 0 0 1, now if we OR any number with this number, it will, there are chances that that will that will increase the number of set bits, but it will never affect these set bits. They are gonna set for always in that number, and whatever number we will be performing bitwise-OR with this number. Okay, so our consideration is our observation is, we have a 3, we have a 2, we have a 1, we have a 5. Isn't it always you will be having the maximum XOR value, maximum OR value from this whole array? Isn't it? Like obviously the maximum number of values you will OR, the maximum number of set bits you will get, and the maximum number of set bits will equals to the maximum number of maximum value of OR. So you will be getting 7 from performing OR on this array, and there is no possible operation, there is no possible subset which can have the maximum OR value greater than this. So remember this, what could be the maximum OR value, because it is the crux of the most optimal solution. Okay, so in the backtracking, we have used here, let me wait a second, let me simply copy this and paste this recursion tree here. Okay, so this is the recursion tree. Now instead of using the hash map or any hashing technique, we will be using simple technique that we will initially find what is the maximum OR value, or what is the OR value of our whole array, which is 7 in this case. Okay, so we will keep track of this, and now we will start our recursion. Whenever we exhaust our array, we will see whether this value is similar to this value or not. If it is similar, then we will increase our count pointer, otherwise we will simply return. I hope you are getting this. Whenever you exhaust, like in this case we have a 7 and we have a OR value of 7 initially, so we will have to count. We will have to consider this subarray, this and this whole subarray, and here you have a 3, so you will don't have to consider because it is not similar to this. Okay, so I hope you get it. Now let's simply go and code it up. So before we have to get a count and we have a OR initialized to 0 now, and nums dot length and my bad, sorry, for and I in nums we will be or is equals to each element. So we have to 0th index, you can go to till nth index and it is the num. Okay, wait, it is the nums and we can our OR value. Okay, and after calling the recursion we have to return simply the count. Okay, so private void solve and idx, and what is the current or what is the length of the array int nums. Okay. If idx equals to n, if current or equals or, then we have to count plus plus, otherwise simply we have to simply return. Now the backtracking logic, we have two options. Either we will take this num, either we will take element at this index, or we will not take this. Now our code is fine. Let's just run it. It should work fine. Yeah, it is running.